3.2 is the converses of the last section's theorems. So the converse of the corresponding angle postulate, or CAP, is if the corresponding angles are congruent, then the lines are parallel. So if you're given these two lines and you know that this angle and this angle, they are congruent, then you know that these two lines are parallel. Same thing with the converse of the alternate interior angles theorem and exterior. If you have these two lines and you know that these two angles are congruent, then by alternate interior angle theorem, the converse of it, then the lines are parallel. Same thing with exterior. If you know that these two are congruent and these two are congruent, then we know the lines are parallel. And same with the same side, interior and exterior. So if we know that 1 and 2 add up to 180, then the lines are parallel. If 3 and 4 add up to 180, then the lines are parallel. Okay, next part is if the lines are parallel, solve for x in the angle measures in each and justify. So I'm going to write if these lines are parallel, we have to look at what the relationship is between these two angles right here. So if this is my transversal, these are on the same side and they're exterior, they're outside. So they're same side exterior angles. So I know that 93 plus x plus 44, so this angle plus this angle have to equal 180. And my justification is going to be by if I know the lines are parallel, so their angles are congruent. So it's the general same side exterior angles theorem. It's not the converse of it. The converse would be, given that these two angles are congruent, prove that those lines are parallel. So we're given they're parallel, so now we can make conclusions. So now I'm going to add 93 and 44. So then it's 137. So 137 plus x equals 180. So what I just did is I combine like terms or I simplify. And now I'm going to use the subtraction property of equality and subtract 137 from each side. So x equals 43. So this is the subtraction property of equality. So to finish it out, I have to find the angle measure. So this one has to be 43 plus 44, so that's 87 degrees. Okay, letter B is these two lines are parallel, just like the directions. And so what is the relationship between these two? Well, I know by vertical angles that this would be 3x. And now both of these are on the inside, so they're same side interior angles. So I know that 3x plus 2x minus 10 has to equal 180 degrees. That's because of same side interior angles. They're on the same side of the transversal and they're on the inside. So now I'm going to combine like terms. So 5x minus 10 equals 180. Add 10 to each side. So 5x equals 190. Divide both sides by 5. X. So x equals 38. Oops. So 38. So now to figure out what my angle measures are, I need to do 3 times 38. So 38 times 3, 8 times 3 is 4, 2, 84. So this one is 84 degrees. which would make this one 96 degrees if I plugged it in too. And then the last one. So what's special about these two? These are on the inside and they're on the same side of the transversal. So these are same side interior angles again. So this means that x plus 20 plus x minus 20 has to equal 180. So 2x equals 180. X has to equal 90. So that means that these two are, this one, if x equals 90, it means that this angle is 110 degrees, and then 90 minus 20 is 70 degrees. Okay, justify which segments are parallel. So if you're given corresponding angles, are the corresponding angles congruent? Then we can say the lines are parallel. Are the alternate interior angles congruent? Are the alternate exterior angles congruent? Are the same side interior angles add up to 180? Do the same side exterior angles add up to 180? That's what we're looking for. So if we know that these pairs of angles are congruent, or that the same side interior add up to 180, then we know the lines are parallel. That's by the converse. So if I look right here, these two, this is my transversal, this would maybe be my parallel lines. These don't add up to 180. So that means that N and O are not parallel. Now I'm going to try this pair. 115 and 65 add up to 180. So if this was my transversal and these are my two lines, then that means that L is parallel to M. L is parallel to M by the converse of the same side interior angles theorem. Because we know that the same side interior angles add up to 180, therefore the lines are parallel. Let's look at the second one. So I look at these two. I'm going to extend this. I think this is easier to see if you extend it. So if this one is my transversal, these two would be same side interior angles and they don't add up to 180. So I know that BA is not parallel to CD. Now I'm going to check, do these two add up to 180? Yes, they do. So this is my transversal. These are my two parallel lines. So then I know that BC is parallel to AD by the converse of the same side interior angles theorem. Because I know these same side interior angles add up to 180, then I know that the lines are parallel. And the last one doesn't have any numbers in it, so I'm going to use markings. These are all congruent by vertical angles. So if I'm looking at these two angles, I don't have anything that they add up to 180. And if I'm looking at these two, I don't know that they add up to 180. I don't have any alternate interior angles. I don't have alternate interior. Nothing right here. Nothing right here. Nothing right here for this transversal. So I can't conclude anything. So I'm going to say nothing can be concluded. Okay, so now we're going to be given statements and we have to say if anything is parallel and why. So I'm going to mark angle 6 is congruent to angle 3. So what kind of angles are there? Well, this is a transversal and these two are the parallel lines because the corresponding angles, angle 6 and angle 3 are congruent. So I know that line M is parallel to line N by the converse of the corresponding angle postulate, which says if the corresponding angles are congruent, then the lines are parallel. What about angle 1 and angle 4? Angle 1 and angle 4 are supplementary. So angle 1 and angle 4 are along this transversal, which would make B and A the parallel lines. So line B is parallel to line A by the converse of the same side interior angles theorem. And then C, what if we know that 2 and 4 are congruent? Well, 2 and 4 are not even on the same transversal, and they're not on the same lines either. So there's nothing that can be concluded. So I'm going to write nothing. Okay, and the third one, or the fourth one, angle 3 and angle 2, so I'm going to mark those up here. They add up to 180. So they're along this line, so this makes the transversal, which makes this the two parallel lines. I always darken the transversal, the line that's up against both of the angles. So these are on the same side, so the parallel lines are B is parallel to A by the converse of the same side interior angles theorem. And then the last one, what about 1 and 6? 1 and 6 are congruent. And again, I'm going to darken the line that's along the both of them. That's transversal. Okay, so angle 1 and angle 6 are alternate interior angles. And since we know they're congruent, we can say that the two lines that cut through the transversal are A and B. So A is parallel to B by the converse of the alternate interior angles theorem, which says that if these two angles are congruent, then the lines are parallel. So these two angles were congruent, so now we can conclude the lines are parallel.